Hello everyone, welcome to my first scripting tutorial. I'll just get right into it. This one's going to be an advanced projectile tutorial, which uses Raycast. So if you ever try to create a projectile system, you probably start off using dot touched event, okay? Like if you were to shoot this ball, you would detect when it would touch, and there's many things wrong with that. It's not very reliable, it's going to miss a lot, which is why we'll use Raycast, okay? Now this is a very it can be a little confusing at first if you're not an experienced scripter, but once you have everything set up, it's very modular and easy to use across many different types of skills. So just give you a little preview of what we're going to make. Something like this. Okay. Boom, 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 boom. Alright. So yeah, let's get into the scripting. Alright, just real quick, if you guys want to learn how to make rock modules like this on screen, or finishers, grab moves like this, just let me know in the comments and I'll make separate videos on that. Start off with a local script in starter character scripts. Right now we're just going to tell the server that the client wants to shoot. So of course, start with your... Oh, hold on. Alright, so start off with your player, of course, like usual, and then we won't really need the character. Now let's just do some services we need. One is actually probably the only one is going to be user input service, so we can actually tell when this person clicks something. So yeah, let's go us.input begin connect function input, GP. Okay, so what this means, this is what they clicked. You know, this is F key, G key, space. I don't know, whatever you want. We're gonna be using E for this. So once they click E, well, first, if you know what this means, this just means if they're like chatting or they're doing some type of input where you don't want to tech them typing. So if they click E while chatting, we of course don't want to fire the fireball. So it's very important to put if GP then return N to make sure we're not firing this when it shouldn't be. Alright, now we're just going to make a remote. You should know this if you're watching this. We'll just call this shoot. That's my bad. We'll just call that shoot. And we're going to do game.replicate storage.shoot fire server. Again, you might want to organize this in your game, but this is just for tutorial sake. And one last thing we'll want is we'll want the player's mouse, because we're making a projectile, so we want to find out where they're actually shooting it. You feel? Alright, let's move on to the server. Okay, we have our client set up. Let's move on to the server now. Start off with normal server script. First, we'll want to detect when the client wants to shoot the fireball. So, pretty basic stuff. Shoot the on-server event. You should know this if you're watching this. Player, and then their connect function, and then their mouse. Player, and then their mouse hit. Alright, so with this, you know, we want to first make sure they're live. So I just have an as live function here. You can copy it down if you want. So we can do character equals player. Oh my god, I can't type. Player.character. Alright, if it's a live character and mouse hit, then let's fire the black hole. So we got velocity. Some things we'll want to declare. You can customize this however you want. Velocity, you can do lifetime, like how long it's going to be in the air for before it breaks. And then radius, which is the impact of when it impacts the ground, how far should it hit the players. And then we're going to have a start pause character.humanoid root part.cframe. So yeah, just center of their body. Pretty simple stuff. So let's move on to creating a little module for the raycasting. Okay, we're gonna call this Hitbox Service. And what we're gonna do here is we're going to have a function that is called function module cast projectile hitbox. And hitbox data. Yeah, they know. Hitbox data will be a table and will include things like the velocity, the starting position, things like that. Okay. So, I'll just start with the middle and we'll go outwards. So right now, we're just going to have this, okay? So what we're going to do is we're going to be constantly calling clock. Or, let me just do this real quick. Okay, start is less than equal to a lifetime, dude. Local lifetime. Hitbox data lifetime. Alright, what this is doing is this is just gonna run a loop for 3 seconds, 2 seconds, however many seconds you pass in for lifetime, okay? And we're storing clock as a variable, so we constantly, it saves some memory. Just makes it a little more efficient because you're saving it in a variable. And we're going to be using run service to wait, if that makes sense. You can just see right here, run service dot step to wait. So this runs after every frame. This is going to run around every frame, so pretty fast. And let's get into the actual meat of the code. Okay. Let's start with a delta variable, which is going to be the time since our last cast. So let's create a last cast variable. We can call this nil. So delta equals last cast and clock minus last cast. So if there is a last cast, then delta will hold the value however many seconds has passed since the last cast. So if last cast but if last cast doesn't exist, we'll want to do if not last cast or delta is greater than or equal to cast interval. All right, now what is cast interval? This is going to be another variable one we'll need. Cast interval. Let's do 0.1 for now. So it's going to raycast every 0.1 seconds. So we can print delta. And I think let's test this out real quick. So we want hitbox service equals game get require game.server script service dot hitbox service. Hitbox service cast projectile hitbox. And we'll just need a lifetime for now. So let's say 3 seconds. So this could work, couldn't work, could or could not work. Let's find out. So we press E. No. Yeah. Okay. Because we forgot to click last cast equals clock. Okay. Sorry about that. See? It's pretty close to 0.1. It's the run service thing is a little bit off, but you can make this 0.01. That's going to make it more accurate. We'll talk about that later. So yeah, delta is the time in between of the last cast. Alright. So we're going to go back to our server script and we're going to create some things we need for the hitbox cast function. Alright, first thing is a direction. Where do we want this thing to go? So we're going to do start pause minus mouse hit dot position dot unit. This is basically creating a like a little unit vector. So say the player points their mouse. Say they point their mouse right there. It's going to create a line that looks roughly like this. So it's gonna be exactly at their humanoid report, but it's going to create a 1 stud long thing, just like that. It's gonna point at say I point my mouse there. It's going to create a vector that points that direction. Okay. And now we'll want the distance between the 2 points, which is start pause minus mouse hit dot position dot magnitude. Distance between them, you should probably know. Now the points, this is where all the points where we want to cast the ray from. So I would create just a little grid here. Right now we're just doing 1, so it would look something like this, centered at the humanoid report. But say you had 4, okay? But we just have 1 right now. But what this is going to do is it's just going to take all these points that you have, okay, and go boom, 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 boom. Raycast them all out. So you can have a whole grid if you wanted to. You can make a triangle, whatever you want. That is just going to be where we're casting the rays from. And just a time variable. Time is distance divided by velocity. Good formula to know. Okay. Cool. Let's create a Hitbox data. Okay, this can be everything we need. First, gonna start off with the points. What starting points do we want? Okay. Now, what direction do we want them to go? The radius on impact. We'll need, how fast you want them to go. The rays. The lifetime. We'll have a variable if you want to visualize the raycast. We'll add that later on. You can have a break on hit. So if it hits something, you depending whether or not what move it is, like a fireball, if it hits a wall, you'd want it to stop. But maybe it's something else and you don't want it to stop. And then the function. This is whatever you want it to do when the raycast actually hits something. So we'll come back to this later. All right, we're gonna cast it. This server script is pretty much all we'll need for now. Yeah, pretty much basically done. So the rest of the work is going to be in here. So we created this thing earlier that this constantly runs every around 0.1 seconds. It's going to cast a ray. Now, how are we going to go about this? So points. Remember that points thing we created before? This thing? This is just table of C frames where you want to start the casting from, okay? Okay. Let's put this up here. Okay. So we're going to loop through every single one every 0.1 seconds, and we're going to cast a ray out of them. So right now we'll want the distance. Let's get the velocity that we passed through earlier too. That velocity. Okay. Now the distance is the velocity times the 0.1 seconds. However many times passed since the 0.1. The cast interval. This is just, velocity is meters per second, so we're canceling it out and we're just getting the meters part, how far we're actually going every 0.1 seconds, if that makes sense, right? Okay. So we'll have a start position, which since it's a C frame, at every point when it start, and then we'll have an end position. End position equals point dot position plus direction times distance. Okay, and I think we'll need that direction thing that we made before. As you can see, this direction, what way is it pointing? Remember that one rule with this thing? Okay. So this will just give us the end direction of where we want to go. And now let's do the actual raycast. So we're gonna have a separate function for this. We're gonna call it cast, okay? And we're gonna want a few arguments, which we'll go into later, okay? So we want the origin of the ray, the goal, the end dot, which would be this, and data, filter type, ignore water. These are functions of the cast thing. So start position equals origin, local, and position equals goal dot position. Equals goal dot position. Now, actually, I'm going to import this convert to vector function, just so you know whatever you throw in, it's going to always give you the correct position. So if it's a C frame, it's going to give you the position. If it already is vector 3, it'll just return whatever you passed through earlier. Okay. Difference is end position and minus start position. Local direction equals difference site unit. Same thing as this. This is what we're doing again. That 1 unit vector and the distance, which is the magnitude. This is pretty similar to what we did here, if not the exact same thing. Okay. Now we're gonna have some ray data. So raycast params dot new, and we're gonna want to have filter descendant instances equals workspace dot map. I always recommend doing this way. Equals filter type or enum dot raycast filter type dot include. Okay. So I like to have, say, the ray shouldn't be able to detect humanoids or anything else, so I just like to create a folder and call that map. You can build your whole map in here. It's only going to whitelist the things in the map folder. Ignore water or true. Alright, now let's actually do the raycast. So workspace or raycast, start position, and the second argument is the direction right here, which is a vector 3. And we're just going to do direction times distance, okay? Now I'll pull up a thing on screen that will help you understand this. And we're going to put in our ray data right there. So this is all you need to do a successful raycast. You can import this into your own games and use this for any times you raycast. It just makes it simpler because this will do all the work for you. So you don't need to find the direction or anything like that. And we're just going to raycast. So we use self, since self is referring to this module. Self cast. Alright, our function wants the start position. It wants a goal. And you can include the rest if you want, but it won't need it because... Did I forget to... So, that, okay. So, it's just going to automatically default workspace on map, include or true. But if you want to change those, you can pass in whatever you like. If there is a result and it hits something, it doesn't hit the air, we're going to remember that function we passed earlier. I'm going to print hit. Just like that. Function. Function result. And you remember this break on hit? Let's pass that. Break on hit. And if we do want it to break on hit, we're just going to break the function. And yeah. So, and we'll finally want to update the points. So, you know, say we're 1 stud forward now. Since 0.1 seconds has passed, say we have moved this far, you know, we'll want to tell the script that, because if we don't add this right here, then it's just going to always be starting at the humanoid report. So we need a step. We need to go boom, 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 boom. Yeah. All right. Let's try this out. Hoping it'll work. Unit is not a valid member of C-frame. Whoops. Just start post opposition there. Okay, yeah. Actually, that'll work. No. Come on. On a number and nil, so... Oh. Whoops. So this is the first cast, so delta actually doesn't exist yet. So we just want to add a if last cast doesn't exist, which it doesn't since it's the first run, we're just going to call it the cast interval. Alright, so it should fire that function regardless of what that number is. Hit, as you can see, and it's printing multiple times. That is not good. Why is that happening? Alright, that is really weird. Okay, well let's do this. Interception equals false. We're gonna make a variable at the beginning of doing if you want it to break on hit and there's an interception, we're gonna break it. I think it's because it's not reaching this. So we're gonna say interception equals true. So it's gonna loop, come back around again, and realize that there has been an interception, and if you want it to break on hit, then we'll stop it. Yep, hit, hit, hit. But you can't see it right now, so let's add a thing right here. All I was gonna do, is create a little radius part like this. Yeah, you want it anchored. Can cloud is false. We're just gonna put this in the script, and then we're gonna pop that in, clone it, radius times 2, since radius is diameter, or sorry, when we're making a sphere, we want the diameter, not the radius. So we would times that by 2 to get that diameter. And I didn't create a visuals for it. Hold on, give me a second. Visuals. This is where all the VFX are going to go. All right, let's visualize this, what's happening right now. Boom. You can't see the ray, but it is working. And it's very accurate because we're using Raycasts, okay? Okay. Alright. Right now, I'm just going to give you guys a quick visualize function if you wanted to visualize this. Here's so, you know, we're converting vector, getting the distance, and we're just creating a part. We're positioning it at the start position, making it face the end position. So, you know, something like this, making it face the mouse. And we're doing it however far the distance is, okay? And we're doing it divided by 2 because we want to put it right in the middle. So, yeah, this is just going to help us visualize it. And if we visualize equals hitbox data. Visualize. Remember we passed this earlier if you wanted to visualize the array. So if you do want to visualize the ray, you can do it. If visualize, then self visualize, start position, comma, end position. Okay. Boom. Now we can actually see what the ray is doing. So let's give that a go. Yep. See that? Boom. Works like a charm. Okay. Let's up the speed a bit. Let's go 500. With touched, that would probably phase through walls, okay? And just to make this extremely accurate, let's try 0.001. So this is going to be pretty accurate, but you might not want to use that low, as it's kind of unnecessary. Boom, see that? Pretty much laser accurate. That's not gonna go through walls. Okay. I'm adding this after I'm done recording, so there might be something like this that wasn't there before, so just ignore that for now. So now we're gonna actually make this damage any players that are in the radius. So let's first start off with a little table of entities, and we'll have a NOR list. It's our character. We don't want to hit our own character, right? So for this, we're going to be using the function get parts bound in radius. The raycast result dot position wherever the projectile hit. Dot position, and then the radius that we declared earlier, and params. So params, we're gonna have to do equals overlap params dot new. And for this, we're first going to start with filter descendant instances. If you have like a special, I'm not gonna do this, but if you have a special like folder for live people, or you can call it, I like to call it entities, you can just put them in there and do workspace.entities, and then do filter type equals enum dot raycast filter type dot include. So it's only gonna look for this entities folder. It's a little faster, but we can actually do that. So we're just gonna put this in the rig. But if you'd also want to have a script that would automatically place players into this folder. We're not gonna do that. So include equals workspace dot entities. Okay, just like that, and then bounded radius. Boom. All right. So now we're gonna do ACMAR in pairs. Parts do. We're gonna first check if its parents is a model, and a part dot pair identified for child class humanoid. Then so you should know what this does. It's basically just checking if whatever part it finds, if it finds like the left upper leg that's in the radius, its parent is a model, and its parent has a child of class humanoid. Okay, so it is a character, and we're just gonna make it called part.parent to make it easier. So we're gonna use that is alive function earlier to make sure the entity's actually alive. We don't want to hurt already dead ones, and they're not gonna NOR list. We don't want to damage ourselves, obviously, and not table.find entities entity. So they're not RB. So we don't make sure we don't account for people twice. We don't want to damage them twice. So all we're gonna do is entities, the length of entities. Oh my gosh, entities +1 equals entity. You can also do table.insert, but I'm just gonna do that. And now we're gonna loop through the entity table we just made. Entity humanoid.health minus equals 10. Alright, so it's gonna minus the health by 10. We're not gonna damage ourselves. And we can check out what this is like real quick. See that? Boom. Damages them properly. So yeah. Let's get into the next part. Okay. We're going to start with translating this to the client now. So in the same script, we're going to start on the same script as last time, and we're going to make a new remote called VFX remote. Now, what we're going to do is we're going to do game.reps, VFX remote, the on-client event connect function data. Okay, this is going to contain the lifetime, the velocity, the start position, everything we need to, line it up. All right, and we'll come back to this in a second. But for now, we're going to go back to our server script, and we're going to actually tell the client when to shoot this. So, a few things we're going to need. We're going to need the VFX remote, of course, so game.replicate-storage.vfx remote. And we're going to do VFX remote fire all clients, the data we want. All right. So what do we want to do? We're going to shoot. We can either have a shoot or a hit. We'll get into the hit later. And we'll need the start pause. So start pause equals start pause. We're going to need the lifetime. As you can see, that time equals t. Distance divided by the velocity. This wasn't used for the casting the projectile, but it is going to be used for how long it'll last for, basically. And we need the end pause, the mouse hit, the distance, how far the projectile is going to travel. And yeah, that'll do it for now. We have one more thing to add, but I don't want to confuse you right now. So this is gonna fire this to this little thing right here, and we'll have either a shoot or hit. So if it was shoot, then else if action equals hit. All right. So let's go back to where is it? This thing I made earlier. This might not be the best model to use, but it'll work for now. Let's just make it a decent color. And yeah, okay. So I'm just gonna put this in replicate storage. I'm not doing any organization right now. I'm just doing the bare minimum. Okay. And let's get that port. So game.replicate storage.projectile clone, or make clone, just like that. We'll start off by positioning it at the start pause that we put in. So the start pause was a C frame, so that'll have to be that position. That might confuse you that I'm using end pause even though it's a C frame, but just bear with me. And we're gonna make this not want to can collide, but we're gonna make it anchored since we're gonna tween it. We don't want it to fall out the map. Okay, then we're gonna do part.parent equals workspace.visuals. Now let's actually do the tweening, okay? You should know how to tween. I'm not gonna show you how to do that. But we're gonna do a tween service. Tween service, create what object we want to do. Part, tween info, okay? Ooh, can't spell. Alright, first one is how long it's gonna last. So remember that time variable, the distance divided by velocity. Okay. That's how far this is how we're gonna line up the velocity with the lifetime. Okay. Using solid dot linear straight line. And we're just gonna want to move it. So since it's already looking at it, as from this, it's looking at the way we want to go. So we're gonna make it go on the z-axis to negative, since negative is forward. Data dot distance. Okay, so the distance was how far between your mouse and your character. So we're gonna travel that amount of distance, and in this amount of time, we're going to do that, which is distance divided velocity. So if you have 1,000 to velocity, time is distance divided velocity, so it's going to line that up with the client. That's very important. And of course, we're just gonna play it. And when it is completed, we're just going to destroy the tween. It's good for optimization, and destroy the part. Okay? I think that's going to do it. Let's just try it out. So it should show that part we were using earlier. Yep. See that? Although, oh, I know. Okay, it's a little delayed, and that's because we're putting this. We don't put that before. And actually, you probably want to quarantine this. Quarantine is a way to run multiple threads. If you've ever used test.spawn, same thing, you know. So that this isn't going to yield anything, you know. So because I did that, I could put this in row 1. If I put this here, there would be no delay. But we're going to do that before we actually put the hitbox. And let's see what this looks like. So there shouldn't be delay anymore. Yep. So there you go. It's destroying the part once it reaches this thing. However, we'll account for if it like hits a wall or a player while it's shooting. And actually, let's, just for testing, let's build a little wall right here. Let's just build a little walls, okay? So one problem with this is right now that we have, if you point your mouse and it hits something, the ball's gonna keep going, because that's what we told the tween to do. It's calculating the distance between your mouse and your character, and it's going that far. And we'll handle that where we actually hit. All right. So remember this function earlier. This is when the Raycast hits something. Okay. So we're gonna copy this, except we're gonna call it hit. Same function it's going to. But for this, really all we're gonna need is the pause, the position where it hit. So we're gonna call it that. And we'll need the radius of the explosion in case, you know, whatever effect we want to do. And yeah. All right. So it goes hit. Oops. All right, hit. So let's create a little hit part, okay? It's not new part. I'll just speed this up for you by doing that, okay? We're making a ball anchored, not collidable. You know, you don't want that going through characters. And we're positioning it at the Raycast position. You know, this is just a basic sphere. You know, you can have better VFX, but for now, I'm gonna roll with that. And we pass in the radius. So we're gonna hit the diameter. We make this 0 because it's gonna go out. And it goes tween service create part tween info dot new. You can make this whatever you want. Let's just go with 1 so you can see it. And you can look up this mean if you don't know that. Okay. Size, vector theta new, diameter. Remember, diameter is radius times 2. And we're gonna make it invisible. So tween dot completed connect function again, tween destroy, and destroy the part since it's invisible. You know, we don't want that to stick in the game and cause a memory leak. Play. And let's remove our little red part where we visualized it. It's gonna get in the way. And let's see what we got. Yep, see that? Boom. Still have that problem where it's going through. We're gonna fix that in a second. Okay. So when you click through, it goes through. Okay, we're gonna fix that. All right, but yeah, as you can see, it works very well, very, very accurate. You know, it's not touched. Touch would be nowhere as near as accurate as this. Okay. So this is very important for advanced games. All right, now let's handle that little issue where it goes through things. One way I like to handle this, there are multiple ways, but one way I found was linking it to a projectile ID using HTTP service. So I'm gonna do HTTP service again. Boom. and there's a little function in here that we can use called generate ready, and if you want curly braces or not. I'm going to print this just so I can show you what it looks like if you've never seen it before. And we're going to send this over to both the hit and we're going to call it projectile, to both the hit and the shoot. Okay? So this is the ID for this move. So if you fire, 5 of them, or if multiple players are firing things, this is going to help keep track of it. Then we're going to have a container, just like this, container. And when we shoot it, we're going to do data.projectile ID equals to the part. Then in the hit function, we're going to want to check if this part wasn't destroyed. So you remember this is the shoring. So if it hit something in between, remember when I was porting a mouse earlier and the thing kept going? So if the projectile actually still exists, we're going to want to get it. So container, project ID. And we're first want to set this to no. Just helps with optimization equals no. And if part, then part, destroy. That's not really necessary since we already checked that, but yeah, you get the point. So, if you look now, boom, ball still exists, destroys it. Okay, you can. This is what a special ID looks like using an HTTP service. So very useful for detecting that. Okay, and that is pretty much everything I have to show. I'm able to show you. You can do 100 radius if you want. Let's test this out. We can set my little visualizing to false, so we can see what this looks like. And okay, this is super fast. Keep that in mind. This is 1500. That's fast. Okay, but look at that. Keeping very good track of that. Okay, you can hit walls. Boom, boom, boom. Actually, it's kind of, as you can see, it's interfering with that. I think that's because, no. Why is that? I think it's okay. I think it's because it's shooting to the left of it, but yeah. But as you can see, it works really good. 3-second lifetime, that will restore itself after 3 seconds. Very accurate. And thanks for sticking around. I hope you learned something from this.